The original Ethernet, which was defined by ARPA Ethernet or DICS Ethernet or 802.3, has quite a few different reference titles, which define the original Ethernet standards for carrier-sense multiple access collision detection. The idea being that multiple systems could exist on the same wire, but only one could transmit at a time. This means that these systems would have to identify when the line was clear to transmit, and would have to transmit without colliding with another system. The reason why it is so important to identify that the line is clear is because the systems use a bus topology. Whether it is the original digital Intel Xerox standard or Ethernet 802.3, they use a topology which is like a single lane street with buses going up and down both sides making stops along the way. And the problem with sending multiple vehicles down the same path and in opposite directions is that eventually they're going to collide. And that's where carrier-sense multiple access collision detection comes in. Now, this has been the same since the very beginning of Ethernet time. They have always used CSMA CD, but we are starting to see some enhancements in the way that Ethernet itself can work. By default, Ethernet is a half-duplex protocol, meaning that it can only communicate when nobody else is communicating. But depending upon the type of technology that we're connecting to, Ethernet does have the capability of full duplex communications. This means that even though I have got a raw transmission rate of 10 megabits per second, I can actually have my aggregate rate doubled when I am using full duplex communications. And this means that I'm using a network interface card that supports full duplex. I'm using the appropriate cable type that supports full duplex, and I'm plugged into an Ethernet switch that supports full duplex. If all of these preconditions are true, then I can have a connection which is a much more scalable connection than what was defined by the original standard.